Imagine you're trying to reach the top of a mountain. You can look up and see the summit, but the path might be obscured by fog or obstacles. This is similar to finding the limit of a function. We know the value we are approaching, but sometimes direct substitution leaves us stranded like being stuck in the fog. Limits describe the behavior of a function as its inputs gets closer and closer to a specific value. While the concepts made straightforward, directly substituting the value can often lead to indeterminate forms like 0 over 0 or infinity divided by infinity. These forms are like dead ends in our mountain path. They don't give us any real information about the function's true behavior. And to overcome these roadblocks and successfully reach the summit, it is to determine the true limit. We need to employ a variety of techniques, and these techniques are direct substitution, factoring, and conjugate that we will be discussing later on.
So now we have here direct substitution, the simplest method of evaluating limits. It involves substituting the value of the variable directly into the function to find the limit. So we have here the equation limit of f of x as x approaches to c is equals to f is equals c. Here are some of the examples of direct substitution. We have here a limit of 2x plus 5 as x approaches to 3 is equals to 11. Another example is limit of x cubed plus 4x squared plus 2 as x approaches to negative 1 equals 5. And the last, we have here a limit of x squared plus 3x plus 1 as x approaches to 2 is equals 11.
Let's find the limit of the function x squared minus 4 over x minus 2 by using the factoring method. First thing you need to do is to factor the equation. 2f of x is equals to x plus 2 and x minus 2. After factoring, we will now rewrite it to get the limit of the equation. Now that we rewrite it, we can now simplify the expression. But since there's both x minus 2 on the numerator and denominator, we can cancel that out, leaving us with x plus 2. Now that we canceled it, we can now directly substitute the 2 in our x. So we now have 2 plus 2 is equals to 4. Therefore, the limit of the function x squared minus 4 over x minus 2 as x approaches 2 is equals to 4.
Conjugate technique is used to simplify limits involving square roots of intermediate forms. To do this, you multiply and divide the function by its conjugate. The conjugate is just the same expression but with the opposite signs in the middle. For example, is in the paper. For example, conjugate of a plus square root of b is a minus square root of b. When you multiply by the conjugate, it removes the square root because of the formula a plus b, a minus b equals a squared minus b squared. This simplifies the expression and makes it easier to evaluate the limit. It's a powerful trick for handling tricky square root or rational expressions in calculus.
We have explored several effective techniques for evaluating the limits of functions, which is this direct substitution, utilizing conjugates to rationalize expressions, and factoring to simplify and cancel common terms. These methods provide a strong foundation for understanding how functions behave near specific points. And I hope you've learned something today with us. Thank you for listening.